Good morning, Mustangs. Welcome back. Um, I want to share a little bit about myself to you guys. I had an injury once years ago. I was mining for gold, and I pulled my hamstring. It was a minor injury. Anyways, today we're going to be working on Unit 1, Section 3 notes. And in this section, we're going to be talking about it's a whole mix of things related to functions again. But it's pretty quick, easy stuff. So let's get started, okay? For the first example here, we're talking about the domain of a function, and we're talking about the range of a function. And the domain is whenever we're talking about the values for x of a function. Okay, so that's all the x values. And so when we're doing that, we don't consider the up and down direction of it. We only consider the side to side. So like when you're looking at my picture, this part right here is the domain. This part right up here is the range. So what we're looking at when we do this is we're saying, where does my graph go to the left, which would be like right here, and then where does my graph go to the right, which would be right here. Doesn't matter how high or how low it is, it's just in between these two regions. This part of my graph is known as the domain. So if we were to look at the graph where it exists, sorry, actually I highlighted the wrong spot there. It actually starts right here because the graph actually begins right here, and that's up here at 1. And then the graph continues right here at 2. Okay, so if we're going to state the domain for this, we're going to look at this value here. It's at -1, and then it's over here at 4. Okay, and that's again directly from the picture right here at -1 and +4. Now, when we look at the graph, you can see, I'll uncover it here just so you can see it. You can see that my graph actually has an included value right there. So because of that, if I was to say, let's state the domain of this, we'd say it's -1. It includes -1. But over on the right side, when we look at that 4, you can see that there's an open circle right there. So it means we get near that 4, but we don't ever actually hit it. Therefore, it's going to be around. So my domain for this is going to be from -1 to +4. Okay. Now, when we're talking about the range of a picture, what we're talking about is the up and down direction, the highest point, the lowest point of my graph. And so in this case, then, what we're going to be looking at is the top of my graph. This graph doesn't go any higher than this point right here, and the graph does not go any lower than the point down to the bottom here. Oops, wrong color. Any lower than this point down here. Keep picking the wrong thing. Okay, so my graph is fixed between these 2 points in the up and down direction. Okay, and so what we're talking about here is we're talking about the y values. So we're not looking at the x, we're only looking at the y values when we're talking about the range. So for the range, we're talking about the y values. Whoops. Values, okay? And so if I was to look at the y value that's right here, it's up at 4, and the y value right here is at -5. Okay, and again, only looking at those y values, which are right there and right there. And if we look at, do we include it or not include it, you can see that there's an actual point right here. It's not an open circle, it's an actual point. And then down at the bottom, it's an actual point. Now, if this did go forever down, it would be the -infinity. And if it went forever up, it would go to +infinity. Just like if it went forever to the right, it would be +infinity. And if it went to the left, it would be -infinity. Okay? So in terms of my range, we're going to say it's from, always start with the smaller number, but -5 to +4. Okay? All right, next. They want us to go ahead and evaluate the function of f of -1. What this is saying is when x is equal to -1, what does my function equal? So what we do is we go over here to where x is equal to 1, and then we're going to go up to the actual graph itself, which is right here, and then we look at what the y value is. That y value there is 3. So essentially, I'm asking you for a coordinate. So when we say f of -1, I'm saying when the x value is -1, oh, I just went to the wrong one. I'm sorry. I went to +1. It's actually to -1 is where I'm supposed to go to. Okay. So let's go to -1 here, and then let's go to the actual graph here at -1, and we can see that the y value here at -1 is -5. Okay. I apologize. I'm glad I caught that. All right. The next one, f of 2. Is saying let's go to where x is equal to 2 on the picture, and let's go ahead and evaluate those values. So let's go to where it's 2. So right here is where x is equal to 2. My graph exists up here at this spot, which is 4. And so that's going to be our answer for the y value. It's going to equal positive 4. Okay. All right, next section, the vertical line test. I already talked about this previously, about if your line hits more than 1 point, it's considered not a function. So when we look at this line right here, you can see that it actually hits 2 points. And the whole premise there is that this is not a function. It's as simple as that. So it's not a function. Okay. Versus when we go ahead and look at this other one here, if I was to draw an imaginary line, and let's take this line, let's go and drag it across. You can see that I hit only 1 point here, 1 point, and I'm always just hitting 1 point on my graph. No matter where I go, it's only 1 point. So as I hit only 1 point throughout my entire graph, we can say that this is in fact a function. Okay? Keep it real easy. All right, intervals of increasing, decreasing, and constant. So decreasing obviously is when you read the graph from left to right. The graph is going down as you look at it from left to right. And as it's going from left to right, if it stays exactly the same, we say it's constant. And if it's going up, we say it's increasing. Now, when we're looking at increasing, decreasing, and constant, we never, ever look at the y direction. Literally, the only time we ever look at the y direction is when we're talking about the range. Okay, so don't fall into this trap of looking at the y. Just look at the x. So when we're looking at this, what we're saying is that in this first section right here, the graph is going down. You could see in this entire section the graph is going down, right? In the middle section, I'm going to go ahead and highlight this as yellow. Just keep it nice and neutral. It's not doing anything. It's staying constant in this section. And then in the next section, it's actually increasing. It's going up. Okay, so there's like regions where it's actually increasing, decreasing, and constant. These points in the middle where they actually change directions are called exactly that. They're called turning points. These turning points are right in the middle, so they're technically decreasing and they're constant, or they're increasing and they're constant. But because they're technically both, we don't include them. So you'll never use brackets when we're doing increasing, decreasing, and constant. So what is it that we do then? Well, we look at the x values and we look at what is the x value where it's decreasing on the left and what's the x value on the right where it's decreasing. And if we look at that, it's at -2 over here to 0. So I am decreasing from -2 to 0. Okay, we didn't look at the y direction, only at the x. For the constant portion, we're looking at this middle portion here where it's constant, and that's from 0 to 2. Okay, again, I didn't look at the y direction, only at the x. And then when we look at the increasing, it's happening from 2 to 4. Now, if this did not have endpoints, so let's say that hypothetically like this right here didn't exist, and instead you saw the graph kind of going up like this, yes, it's going up, but what it's really doing is it's going to the right and it's going up. I don't care about the up direction. The up direction just tells me that it's going up. So if I was to say then, well, where is it increasing? The modification here would then be, that would be increasing from, say, 2 to infinity, meaning it's going up forever. It's increasing forever as we go to the right. Okay, and that's because infinity is this value all the way over here. Okay? All right, so increasing, decreasing, constant. Let's take a look at this picture right here. Determine the intervals over which the function is increasing, it's decreasing, or it's constant. Now this graph, this first one, is a little bit deceptive. What happens is this graph, when you look at it, it starts off increasing, and then you look, it looks like it kind of tapers off and it really doesn't do anything. Like it almost goes constant and then it continues up. If you actually trace this on the calculator, this never actually stops increasing. It's always increasing. So when we look at the end of this graph, this behavior right here on the end of this graph is going down and to the left. So it's going left and it's going down. Okay? I don't care about the down direction at all. That doesn't matter to me. The only thing I care about is the interval from the x direction. This graph goes to the left forever. So since it's going to the left forever, it's going to be negative infinity is where the graph is going to start. The second portion of this graph is going up and to the right. So because it's going to the right and it's going up, it does this forever. It goes to the right forever, and it goes up forever. And because of that, to the right is infinity. And as I look at this from left to right, it's always increasing. okay? So if I was to say then, what's the interval where it's increasing? It's always increasing as we go from left to right. All the way left to all the way right, okay? All right, looking at this next one here, we've got 3 separate intervals taking place here, all right? Our first interval is right here where it cuts off, okay? This is increasing at this point, and more importantly to recognize is that it's doing this right here. You got that arrow right there. I'm gonna make it black so you can actually see it, okay? Then we've got this region in the middle where it's decreasing, so it's going down right here, okay? And then we pick up again and turn, and we go continue up, back to the right, up and to the right again. So this is increasing from this point on, okay? And again, the arrow on the top right side here is this, it's going to the right. So it's going to the right and up, it's going to the left and down, okay? And again, I don't care about the up and down direction. All I really care about is the left and right directions when we're talking about interval, okay? So for this first area here, it goes to the left forever, okay? And then what happens is right here at that point in the middle, it stops going increasing, and that's it when x is equal to 1, okay? And then the next area where it's going to be increasing is going to be from 1 to infinity. So it picks up right here at 1, and it goes to the right forever, okay? Let me go ahead and move this down so we can see a little bit better. There we go. Okay. Where is it decreasing? The decrease happens from right here to right here, and that is again from -1 to +1. You can see it's going down as you go from left to right. All right. Let's look at this piecewise function here. So don't worry about the actual like piecewise function that's going on there. Let's just look at the picture in this instance, okay? So it's going this direction here. What's happening in this first part is as we move along here, it is going up, so it's increasing, and then it turns and goes constant, and then it turns and goes down, okay? So we've got 3 separate sections here. You've got it increasing in this region. We've got it constant in this region, and then we've got it decreasing in this region, okay? So 3 separate areas there. That looks like some sort of flag. I have no idea what country it would be. Look it up and let me know. Post it in the comments. So anyways, the interval where it's decreasing here, again, we only care about the x values. So over here is -infinity. And then the x value at this point is at 0. Okay, so from -infinity to 0. I should do this in green. From -infinity to 0, it's increasing. Okay, it is constant from 0 to 2. So from here to here, it's constant. And then for the decreasing, it's decreasing from 2 to infinity over here. So decreasing from 2 to infinity. And beyond. I feel like Buzz Lightyear here. To infinity and beyond. All right, anyways. Sorry. Let's move on, because I'm an idiot. All right, relative maxes and mins, super easy. A relative max is any turning point that we have inside of our picture. It's a turning point. That's really all it is. So when we look at this, this is a relative min, this is a relative max, this is also relative max, and this is also relative min. Mins are at the bottom, like the minimum, the smallest amount. Maximums are those highest points, those maximums, those peaks. Nothing's larger than those. When we look at this right here, it goes up and down forever. And so if I was to say, is there an absolute max? An absolute max means there's an absolute top. It never goes higher than this point. Well, because of this right here, it goes up forever. It has no absolute max because it goes up forever. If I look here, it goes down forever, so it has no absolute min. But it does have relative maximums and minimums because it's got those turning points inside the picture, okay? So when we look at a graphing utility and we're trying to find a maximum or a minimum, just graph it and then look at the point. So in this case here, 3x squared minus 4x minus 2, I went ahead and graphed this on Desmos. all you have to do is literally just zoom in on the point and then just touch that point and it'll tell you where it is. So this one is at about 2/3 and then 3 1/3. So the solutions 2/3 and then 3 1/3, which is at 2/3 and then 10/3. Okay, and I'm sorry, it's a negative, so I should, oops, sorry, it's a negative 10/3. Okay, so that's as easy as it is. If you want to know how to do it on the graphing calculator, just see myself, or see me or your other teacher, just because, you know, sometimes you just need to see it by hand. It's pretty easy to do on the graphic calculator, but Desmos is my favorite one right now. Okay. All right. So how to sketch a piecewise function? What is a piecewise function? This is a graph where we're just taking pieces from each equation and putting them into one picture. So this right here would be one equation that we graph all on its own, and then this is another equation that we would graph all on its own. But those pieces are going to make up our entire picture. So how do we go about doing this? Well, let's start first with this. We're going to make this whole thing blue, okay? And I'm going to explain what we're going to do here. This first portion of the graph says that if you think about this, it says that y is equal to 2x plus 3. So the graph for y equals 2x plus 3 means we're going to begin at 3. We're going to rise 2 and run 1. And I'm just going to keep doing this until I have my entire graph. Okay, we're just going to keep following that trend. And we end up with this line right here. Okay, this is the line that goes forever here. Now, the directions for this, when we say a piecewise function, it says, I only want to see this graph when x is less than 1. So that means where x is less than or equal to 1 is the only part of the graph I should see. I shouldn't see anything else. So what does that mean? Well, that means we're going to cut off our graph here at some point. How do we do that? Well, here's where x is equal to 1. Go up to where my graph is equal to 1, which is right here. And where is that? Well, let me cut it off here. Okay, to the right is more, because these are x's, oops, these are more. So over to the right is where those values are more than 1. The x values are more than 1. And over the left, this is where the x values are less than 1. So what we're going to do is we're going to use that line right there to kind of cut this off for us and say that I only want to see this graph from here. I only want to see the graph where it's to the left of this line right here. Well, that is this portion right here. That's the part that's to the left of it. That means that everything to the right of it, I want to get rid of. So how do we do that? Well, we just simply erase it. Okay, so I'm going to erase part of it. We're going to get rid of all of this that's to the right of it. It's gone. Now, it says it's going to be equal to, so I can actually have a closed circle right here, and we're done with that graph. So now let's continue on to the second part here, which is negative x plus 4 when x is greater than 1. So to do this, we're going to have y is equal to negative x plus 4. Let's graph this entire line first. So we're going to start at 4, and then we're going to go down 1 over 1. And we're going to continue this graph. Just going to go ahead and fill it in real quick. Okay, there's my graph. And with the instructions here, it says I only want to see this graph when x is greater than 1. So let's go again to where the cutoff for this is. Right here is where x is equal to 1. So let's make an imaginary line right here. All of the values to the right are more, and all the values to the left are less. Since I want the values that are more, I only want the part of the graph that's to the right of this spot right here. So that means that what we're going to do is we're going to look at this point right here as my cutoff point. I want to keep what's to the right and get rid of what's to the left. Okay? So we're going to go ahead and chop this off right here. We're going to get rid of all this and that. Okay? So now the final question we have to ask is it an open or a closed circle? When we look at this right here, because it's greater than, this would be an open circle. Versus this, it was a closed circle. So there we go. This is what our piecewise function ends up looking like. Okay? All right, even odd functions, and I think this is our last thing we're going to be doing here is even odd function. Even odd function is something more just about recognizing really quick strategies about what a graph would look like. If an even function happens, we know that we have symmetry with respect to the y-axis. So what that means is that whatever's on the one side is the same as what's on the other side. So what you'll notice is when we look at this, is that if I put in an x value, I get a y. If I put in the opposite x value, I get the exact same y. So if I put in an x value, let's say I put in a 2, and I get, let's say, 8 for the y value, and then I put in a -2 and I still get 8, we call this an even function because there's symmetry with respect to the y-axis. Okay. When I do symmetry with respect to the origin, it's different. What ends up happening is it reflects over the origin. So the origin being right here. What happens is this portion of the graph right here, technically, when we do this, it's going to actually reflect twice. So what will happen is this graph right here will actually go ahead and reflect over this direction. Actually, let me see if I can do this. I can't do the flip. It's going to look something like this if I reflect it over the axis. And then if I reflect it down, it's going to end up reflecting and looking like this, and it comes down over here. It's hard to do on this, but the idea being that it reflects both over the x and over the y. Well, why does it reflect and what happens? Well, the symmetry with respect to the origin says that if I put in an x value, let's say that this is 2, 5, then what I do is if I put in the opposite x value, I end up with the opposite y value. So I end up with a -2 and a -5 over here. So they're opposites. So how do we test this? How do we test if something is an even or an odd function? Well, it says simply here, if you read all this stuff, there's a lot of words. Here's what it literally says. If I put in the opposite x value and I get the same y value, it's an even function. And if I put in the opposite x value and I get the opposite y value, remember this is a y, right? F of x means y. Then it is an odd function. It could very well end up being that it's neither. What would neither look like? Neither would be like if I did something like this. Okay? There's no symmetry over the axis right here. It's not the same on the right side as it is on the left side. We don't have it reflected over the origin here, like over the origin in this direction, and we don't have it reflected over the origin in this direction. So this is not an even, it would be a neither. Okay? So let's test these. Let's see what happens and how we actually determine these, okay? What we do is we're going to put the opposite x in and see what happens. So if I go g of -x is equal to -x to the third minus -x. Okay, we're doing a right now. G of -x ends up equaling -x cubed plus x. Okay, now let's look. Do we have the exact same thing? Clearly, these are not the same. Are they the opposite of each other? This and this are opposite each other, and this and this are opposite each other. So because they are opposite each other, we would say yes. I'm sorry, not yes. My bad. We would say, let me erase that whole thing. We would say odd. Okay. Let me show you what that graph looks like. X cubed minus x, y equals x raised to the third minus x. And you can see that there is that symmetry with respect to the origin in this picture. Okay? What we see on the left side of this equation is the same as what we see on the right side. It's just been reflected. Okay? Let's go ahead and try B. H of x is equal to x squared plus 1. I'm going to put in h of -x. And what's going to end up happening is we'll have h of -x is equal to positive x squared plus 1. And you ask yourself, well, do I get the same thing? Here's my original function. Here's the opposite function. We get the exact same thing. And because of that, this is what we consider an even function. And if you recognize what this is nothing more than a parabola with a graph that's been shifted up 1. And you can see from there, there's symmetry to the right of the y-axis as there is to the left of the y-axis. Okay. Lastly, let's look at C. We have f of x is equal to x cubed minus 1. If I put in -x here, we end up with -x cubed minus 1. So we end up with -x cubed minus 1. And when we look at this, we look at it and ask, okay, is it the same? Clearly, these are not the same. Whoops, that one. They're not the same. Oh my gosh, you can't even see. I'm in the way. Sorry, let me move myself here. Oh no. Everything's falling apart here. Sorry. All right. So anyways, everything here when we look at it is not the same, right? The x cubes are not the same, but the -1 is the same, so it's not an even at this point. All right, is it odd? Well, the negative x cubed and x cubes are opposite. However, the -1 and -1 are the same. So because not everything is opposite and not everything is the same, we would call this neither. Okay, and let's look at what this looks like. X cubed minus 1. Y equals x cubed minus 1. And we can see that what ends up happening is that you see the symmetry on the right side is left side, but it's not over the origin. You can see that my graph actually passes through the that point right there. Okay, because it passes through this point right here and it's not up here at the origin, what ends up happening is we don't have symmetry with respect to the origin. It's not an odd function. Okay, that concludes the notes over section 1.3. You guys are doing amazing. Keep this up. I'm proud of you. I would be more proud if you were to like and subscribe to my channel. You take care and have a wonderful day.